Hello and welcome to the video series on the Tour of Go exercise walkthroughs. Today's video covers the fourth exercise, Fibonacci Closure, from the Basics module inside of the More Types, Structs, Slices, and Maps chapter. Rather than just showing you my solution directly, I will explain all the necessary golang concepts in context for you to impart with a deep understanding of what each and every single line of code really means. What is the question asking of us? Let's have some fun with functions. Implement a Fibonacci function that returns a function, a closure, that returns successive Fibonacci numbers 0, 1, 1, 2, 3, 5, and so forth. In essence, we're going to use a closure to generate the Fibonacci sequence. I'll be explaining the closure concept a little bit further down the line once we get to implement it. But for now, let's make sure we understand the Fibonacci sequence. If you're not familiar with the Fibonacci sequence, it's a sequence of numbers that starts with 0 and 1, and then each successive number is defined by adding the previous two numbers. 0 and 1 sum to 1, 1 and 1 sum to 2, 1 and 2 sum to 3, 2 and 3 sum to 5, 3 and 5 sum to 8, and so forth. As per usual, let's take a look at the provided starter code. The main package is declared. We're importing funct. Next, we have the function Fibonacci, and the comment says Fibonacci is a function that returns a function that returns an int. So exactly this. Inside of the main function, Fibonacci is called, and the return function f from Fibonacci is called 10 more times and printed to standard out in a for loop. First course of action is to get this program to compile, missing return. Let's just fulfill this function type contract as easily as possible by returning a func, which returns an int. And then inside of here, we return some number. That should now compile and run, giving us 42 10 times. Let's now actually implement the algorithm. So we'll say first, second, equal to 0, 1. We declare first and second outside of this return anonymous function as they'll be captured by the closure. And then inside this anonymous function here, we want to create a current, which is first. We'll return current, and then we'll update first and second. So we'll use a multi-assignment to update both variables. If we didn't do this in a single line, we would actually need a temporary variable to store an intermediate state. But with the multi-assignment, we can just do it in one line. All right, so let's run. And we see the first 10 Fibonacci numbers printed to standard out. Perfect. So how does this work exactly? We can think of the closure as a generator function for the next number in the sequence every time it is being called. Even though the outer function Fibonacci has returned, the variables first and second get captured by that closure. The closure is f. And every time f is called, the first and second variable are being updated. Essentially, f is a place in memory, the heap, where we have the variables first and second, as well as a reference to the function that manipulates them. So we have a reference to this code. You can kind of think of this as a slice descriptor in the sense that the closure is this invisible thing in the background that captures the environment. The first time I saw an anonymous function, I thought of it as some kind of black magic that's going on in the background. In reality, all it does is the closure captures the anonymous function and the environment this anonymous function is operating on. And that's it. So every time Fibonacci is called, a new closure is instantiated. If we were to copy all of this code, maybe call this F2 and make a call on F2, we can add a line in between. And when we now run this, we can see the first 10 Fibonacci numbers from F, and again, 10 Fibonacci numbers from F2. So F2 and F, they operate on distinct environments, yet they reference the same anonymous function code. Great, so our Fibonacci function works. It's using a closure. There's another way we can implement the Fibonacci number, which doesn't use current as an intermediate variable before updating and uses defer. With this solution, we return first directly, and execute this update statement after the function has returned. And in order to do this, we will use defer, func, move this update inside of the defer, and call the function. So defer expects a function call, so we just created this little anonymous function here to be executed, which all it does is execute the update statement of first and second. Even though we have a function which returns a function which makes use of an anonymous function, I find the solution to be quite elegant. And that's all for this exercise. I hope you've gotten something out of this walkthrough. Thank you so much for watching, and I'll see you in the next one. Peace.